All right, let's continue with our practice here. We have f is a function given by f of x equals 2x e to the 2x. And we want to find the limit as x approaches negative infinity and the limit as x approaches infinity of f of x. We want the absolute minimum value of f, and we're going to justify our answer. We're going to find the range of f, and we're going to consider a family of functions defined y equals bx e to the bx. So the same form, just some non-zero constant b, and we're going to show that the absolute minimum will be the same for every non-zero value of b that we could put into that equation. All right, let's start out with our limits. So limits as we go to negative infinity and positive infinity. This is actually a calculator-based question. From this practice exam, we can use our calculator. So we can just calculate this particular function and take a look on our graph. Okay, so I'm going to type in our graph here. I'm going to go to y equals, and let's put in 2x e to the 2x. So there's our function. Let's go ahead and graph that. And there we go. We can see right away that this is heading off right to infinity here. So it looks like as this gets bigger, as x goes to infinity, our function goes to infinity. This, we're going to see what happens out here, appears to be going to 0. If I hit my trace, oops, back to my graph, if I hit the trace function and we just keep going out here to the left, we are getting closer and closer and closer to 0. Even by the time we're getting to -5 and -6, we're about 0. We could verify this with our limits if we just take, the limit as x approaches negative infinity of 2x e to the 2x. So as we go to negative infinity, this part of the function is just going to get bigger and bigger negatives. So we're going to get a bigger and bigger negative idea here. So we're going really big. But let's take a look at this piece right here. If I make this number negative, we get 2 to the negative. We have e to the negative exponent, which puts it on the bottom. So this is going to be e, and we get 2 times infinity. So this is just getting, again, bigger and bigger and bigger. Well, as this gets bigger, and it gets bigger much faster than this one will, we're going to get -1 over some big number here. We're getting closer and closer to 0. Now, it is negative, so we're going to 0 from below. That's really what this is saying. But this is approaching a 0, because this number here is just getting bigger and bigger and bigger, much faster than this number up here is getting bigger and bigger and bigger. How about on the other side? The limit, the limit as x approaches infinity of 2x e to the 2x. Well, now we can see that if we start putting in bigger and bigger numbers here, this is just going to get really big, really quick. So that is heading off to infinity. So we can verify it with or without the calculator. Okay, what is the absolute minimum of f? Well, minimums occur when our first derivative is equal to 0. So we have to find our derivative here. We need the derivative of f of x. And I have 2 x e to the 2x. So we got a little bit of product rule. Product rule says the derivative of the first, and that is the 2x part, times the second, plus the first, times the derivative of the second. So we need the derivative of this e to the 2x, which in itself is chain rule. E to the 2x, derivative of the outside, times the derivative of the inside. So I'm getting e to the 2x, or sorry, 2e to the 2x, plus this is 2x. I'm just going to move this in here, 2e to the 2x. And I've done that really because I can now see I can factor out the 2e to the 2x. So I get 2e to the 2x. That will give me 1 plus 2x. And I'm doing that because it'll actually help me find my zeros a lot easier. Remember, we want this to equal 0. So that is going to equal 0. Well, this will never equal 0, because even if we put zeros in here, that's just going to be a 1. And if we remember our e to the x formula, or graph, it's not going to equal 0. So our big question is, when is it happening over here? And if we set that side equal to 0, when x is negative 1/2, we get a 0. I'm going to try and squeeze this all in, so I'm going to go now and make my little chart to verify. I have negative 1/2. Okay, let's pick up something less than negative 1/2. I'm going to put in negative 1. Again, this is a calculator question. I'm not going to video it, but I could punch this right into my calculator. 2 times negative 1 times e raised to the negative 2. 2 to the negative 1 is negative 2. And if I do that, I get a big negative number, so that is going down. I'm going to try something bigger than this. 0 works. If I try a 0, again, if this is 0, that just means this is a 1. 2 times 1, that part is 2. And we get 2 times, if this is 0, that's gone. 2 times 1, that is 2. That is a positive number, and it's increasing. So the absolute minimum occurs when x is negative 1/2. That's when it happens. The question says, find the absolute minimum value. We want the value when it is the minimum. So we need to put 1/2 into our function. We got to put 1/2 into the function. So I'm going to go up here, and I'm going to take f of 1/2. 2 times 1/2, and we get e raised to the 2 times, sorry, this is negative 1/2. So that cancels, that's a negative 1. And again, this cancels, that's a negative 1. So this is e to a negative 1. The negative exponent just moves it to the bottom, and we get e. So the actual absolute minimum value is negative 1 over e. Remember, this negative 1/2 is when it occurs. This is the actual value of the minimum. Okay, let's keep going. Now we want to find the range of f. Well, we did just find the absolute minimum value, right? We found the absolute minimum. We said that was negative 1 over e was our absolute minimum. So we're just really going to write out the range here. Range is all our y values. We know the upper limit goes to infinity, and it is greater than or equal to 1 over e. So we can do something like this. Here's our range. All right, finally part D, we have this family of functions y equals bx e to the bx, and we want to show that the absolute minimum is always going to be the same no matter what value of b we put in there, non-zero. The absolute minimum is always going to be the same. So absolute minimums, remember, occur when the derivative is equal to 0. So let's go ahead and find the derivative of this. Again, we're thinking product rule, bx e to the bx. So the derivative of the first times the second plus the first times the derivative of the second, again, is some chain rule for the derivative of the second. And we see, just like we saw before when we had a 2, I have b e to the bx. If I move this in here, I have b e to the bx. So I can factor that out. b e to the bx. That's going to leave me 1 plus bx. E, we've already said before, will never equal 0. Okay, so any function with the b in here, that's never going to equal 0. So this is our factor that we have to worry about to equal 0. That is going to be 0 when b is 1, or sorry, when x is negative 1 over b. So the absolute minimum will occur when x is negative 1 over b. No matter what b we put in there, that's when it is going to happen. And then if we put that back into our function, just like we had before, we're going to get the same value all the time.